for that introduction. Yeah, my name's Paul Dando. I work in the computing and software support team here at ECMWF. I believe that yesterday you had the Mars Day, where some of you will have downloaded some data from Mars, those of you who attended those sessions. I don't know whether any of you tried to look at the data, but it's usually what you get out of Mars is encoded in GRIB. That at least is the NWP data, the data that comes out of the IFS model is encoded in GRIB. And this morning's session from now until lunchtime, we're going to teach you a little bit about GRIB and how to decode it with our ecCodes library. So I thought I'd start off by telling you a little bit about what is GRIB. Well, GRIB, it's an acronym. It stands for Generally Regularly Distributed Information in Binary Form. I think it used to also be referred to as gridded in binary. It's been around for quite a while. It was first defined by the WMO for Commission for Basic Systems in 1985. So it's 40 years old this year. Happy birthday, GRIB. And it's designed specifically for the exchange of large volumes of gridded data. So typically the sort of output you get from a numerical weather prediction model. Now, the GRIB format itself is machine independent. So we can create it on our Atos HPC from when the model runs, and we send it out to our customers and they can read it whether they're on a Windows PC, a Windows laptop, a MacBook. So it really is machine independent, but it's a binary format. So it's not human readable. And if any of you have tried to look into any of this GRIB data that you've downloaded from Mars, you'll see that you can't really read very much. In fact, usually about the only things you can read in a GRIB file are these characters here, GRIB, and then there will be a 7777, so 4 sevens at the end. These are the beginning of message and end of message indicators. And they're about the only things that are readable. So you really need to use some software, both to encode it in the first place, but also to decode it. Now, currently, there are 2 different coding standards, GRIB coding standards that we are using at ECMWF. We use GRIB Edition 1 and GRIB Edition 2. So GRIB Edition 1 is currently used from our operational forecast for all operational pressure level fields. Also, if you get data on potential temperature or potential vorticity levels, and also most surface level data. The model level data, so these are the hybrid levels that are the model levels that go vertically in the atmosphere. This has been encoded in GRIB Edition 2 since the 11th of May 2011. So that was when we introduced GRIB Edition 2 for the first time in our operations. And since then, we've also started to encode some new surface data in GRIB Edition 2. Now, GRIB Edition 1 has been deprecated by the WMO for a number of years. And I think in principle, if you are sharing this data, you are not supposed to share data that's only in GRIB Edition 1. All data that goes out on, for example, on the general telecommunications system, or now on WIS2, has to be encoded in GRIB Edition 2. So we've been planning this for a number of years now, and we actually plan to migrate fully to GRIB Edition 2 by the end of 2026, so by the end of next year. And there's a presentation that will follow this morning where you will be told much more about our plans for migrating to GRIB Edition 2. Now, in the migration to GRIB Edition 2, this will mean everything. This will be all of our operational data. It'll also mean that the new reanalysis data will be encoded in GRIB Edition 2. However, we will not go back in the archive and re-archive data that has been already created and stored in GRIB Edition 1. We will not take that out of the archive and re-archive it and re-encode it. So we will always need to have a mix of GRIB Edition 1 and GRIB Edition 2 in the archive. And so we'll always need to be able to handle it and to be able to decode that data. Now, thinking about the structure now of the file. So you've got these files from Mars, and we talk about a GRIB file. But what a GRIB file can contain is several messages. And these can be a mix of GRIB Edition 1 and GRIB Edition 2. So you can have maybe message 1 here would be GRIB Edition 1, message 2 and message 3 could be GRIB edition 2, message 4, etc. could then be GRIB edition 1 again. Each of the messages contains several sections. They are different in GRIB edition 1 and GRIB edition 2. So you can see in GRIB edition 1, we just have these 6 sections, whereas in GRIB edition 2, we have 9 sections. The first section is this section 0, the indicator section. That's the same in both editions. And that is the part where you see this GRIB written. This is the start of message. So you know you have a start of message. You also have in here the section where it tells you which edition it is. So you'll have that this one would be edition 1, this one would be edition 2, and you have the length of the message. And the length of the message points at this section 5 in GRIB edition 1 or section 8 in GRIB edition 2, which is the end of message. And that is the 777 that you see here. So you can always, this is a way that it checks, and you can always check that you've got the full message and you know whether there's been any corruption. The next part that's of interest is section 1, and that is the product definition section in GRIB edition 1, which is actually then section 4 in GRIB edition 2. And this is where you get the information about which parameter it is, which forecast it came from, what the time of the forecast was, etc. That's all in the section 4. In GRIB edition 2, section 4 is template driven. So depending on the particular parameter being encoded, you may have different templates, which means the coding is different and the section size changes. You also have a grid definition section or grid description section, section 2 in GRIB edition 1 and section 3 in GRIB edition 2. Interestingly, in GRIB edition 1, this is actually an optional section, but I can't understand why anybody would want to have a GRIB message without a grid description of some sort. So in ECMWF data, the grid description section is always there. And that describes your latitude, longitude grid, if you like. It tells you where it starts, where it ends, how many points there are on each parallel. The next section in GRIB edition 1 is the bitmap section. This is also optional, and it's not there in most cases. This is used when you have missing data values. So if, for instance, you wanted to encode a field which is only available over land, you do not want to put data values over the sea. So what you have is a bitmap where you have the bitmap is set to 1 at the points over the land, and it's set to 0 at the points over the sea. And then in the binary data section, where the data values are, which is the thing you're really interested in, where that's stored, you only store the data values over land. So you read the bitmap, you see a 1, you say, I've got a value, and I put that in my values array. If you see a 0, you put some missing value to indicate that the value is not there. And so that's basically it. Now, talking about the messages again, typically at ECMWF, one message is one parameter at one forecast time step on one horizontal level. But you can, in GRIB edition 2, you can start to repeat sections. So you can actually have, in some way, more than one piece of information encoded in a GRIB. ECMWF does not use this, but I believe the Japanese Meta Agency does, and they will encode 2 wind components in the same message. So you'll have the U and V components of wind in the same message. So that's the structure. Fortunately, you don't really need to be aware of this when you're decoding the GRIB yourselves as users of GRIB, because we've provided a nice library called ecCodes. So this is a package that we've developed. In fact, we were asked to develop this by the WMO when GRIB 2 was being introduced in the early 2000s. And we were asked to introduce this for the decoding and encoding of GRIB messages. Now, originally, it was just decoding and encoding GRIB messages. And it was actually, in those days, it was called GRIB API. We then realized that the same decoding and encoding engine could be used for encoding and decoding buffer messages, which is what you'll learn about this afternoon in this afternoon's session. So today we will look at decoding GRIB edition 1 and GRIB edition 2, and believe it or not, WMO are already in the process of defining GRIB edition 3. But you can also use it to encode and decode buffer edition 3 and edition 4, and also something called the WMO GTS abbreviated headers, which are basically nowadays are on the way out. But these were headers that went on the top of all the GRIB and buffer messages for information that was sent out on this global telecommunications system. Now, what the ecCodes package provides you with is a set of command line tools, which is mostly what we will use today. These are called the GRIB and the buffer tools. And these give you a quick and easy way to access, view and manipulate the GRIB data. But it also provides APIs, which you can call from C, Python, and also Fortran 90. The library itself, originally written in C, but it's now being migrated to C++. So the C is a native access to the library, if you like. So the idea is that this is to provide an easy and reliable way of encoding and decoding GRIB1 and GRIB2 and GRIB3, or buffer 3 and buffer 4, using the same function calls. It's all released under the Apache 2 license, and it's available on GitHub, and it's available openly for development, and we have taken developments from external people in the past, and if you want to contribute, you can contribute via GitHub. We have a way for you to do that. Now, the way ecCodes works is it really treats the GRIB message as a database. So you make a query on a key, and a key is some representation, is the name of the information that is encoded in the message. And this is really taken straight from the WMO documentation. So what you will find is you'll have key names, something like number of points along a parallel. That's taken because you'll find in the ecCodes documentation, they will say some number of bytes in the GRIB header in section 4 of the GRIB2 data. Well, actually, this would be the GRIB definition section, is the number of points along a parallel. So what we do is we take that, we capitalize, we remove the spaces and capitalize on the word breaks apart from the first word, and that gives you the key name. Now, these can be quite long, of course, so we do actually have some aliases. So rather than number of points along parallel, you'll be pleased to hear we have NI for this as an alias, and also then we have number of points along the meridian. You have NJ. Other keys that you could use would be the date, for example, or data date, and the time of the forecast, the short name and the param ID. These are the other sorts of keys. Now, if you want to know about the keys, all the information is in this link, and we have a website which is kept up to date with each new version of ecCodes that we release. And the keys are there, and you can access them either via GRIB Edition 1 or GRIB Edition 2, or what are called edition independent keys. So these are keys that are agnostic to the GRIB edition in which the message is encoded. And these are the ones that we really advise you to use. Now, there is a disclaimer at the bottom of here, because of course, the official source of the documentation for GRIB is held by the WMO. And if you really want to see what the source of the documentation and what the documentation says, you need to go to the WMO. But this is what we provide for ecCodes. So if we look at some of the possible key values, and we think particularly about the parameter, you can see, in fact, the way the parameter is encoded is very different between GRIB1 and GRIB2. And Seb will talk more about this in terms of the migration from GRIB1 to GRIB2 later. But so typically in GRIB Edition 1, you would identify a parameter, say mean sea level pressure, in terms of the center, the table 2 version in which the parameter is taken from, the indicator of parameter, which is a number which indicates which parameter you've got, the type of the level, so whether it is a hybrid model level, whether it's a pressure level in isobaric in hectopascals, for example. And then you've got the level number itself, so whether it's 1000 hectopascal or 100 hectopascal. And then in GRIB Edition 2, you can see it's really different. There's a lot more information. You have a key called discipline, which is usually we use meteorology for this, but we also have some hydrological parameters. You have parameter category, which could be moisture or temperature. Then you have the parameter number, which can be the type of parameter within that category. And you've got several different categories, each with a number of different numbers associated with them. But then to identify the parameter itself, you've got a parameter temperature, but that temperature could be temperature at 100 hectopascals or temperature at 1,000 hectopascals. It could also be the 2-meter temperature. So you need to know the type of the first fixed surface and the value of that, which could be it's a height above ground and it's at 2 meters, or that it's isobaric in hectopascal and it's 1,000 hectopascals, for example. You can even go further and have the type of statistical processing. This is all you would need to know about the parameter. So that's actually quite something which is quite complex. And what we've done in ecCodes is to simplify this by providing something called the parameter namespace. And basically all of the parameters have a unique param ID, which maps you onto those keys that we saw on the previous slide. So for example, here we have something, a param ID 151, which has a short name MSL and is actually the mean sea level pressure. And associated with that, we also have the center, which for ECMWF will always be ECMF. Is only 4 characters for the center names, so ECMF, or it has a numeric ID 98, and it's actually this 98 as an integer which is stored in the GRIB message, not the ECMF. You would find 98 as the number. ecCodes will translate that into ECMF for you, and you have the unit associated with the parameter as well. Now, this particular set of keys is called the parameter namespace in terms of ecCodes. ecCodes provides a number of additional namespaces. So, for example, as well as parameter, we have time, which tells you the date of the product was created, at which time. So these would be your base date and base time, if you like, or your analysis date and analysis time. You've got your forecast step, so at which hour. So this is like the Mars step, if you like. You also have something which gives you the validity date and the validity time of the product. You have geography, which tells you about the latitude and longitudes of the grid. You have vertical, which gives you some information about any vertical keys that are needed to have information about the message. Statistics gives you the maximum, the minimum, the average, the standard deviation, and the kurtosis, for example, some information about the data values. And then we have a parameter space called Mars, which is used by Mars. So these are effectively the Mars keys. These are what you used yesterday to access the data with Mars. So things like date, lev list, time, step. These are all Mars keys and are provided by ecCodes. Now, I said before that ecCodes is trying to provide a way of getting information from GRIB messages using the same function calls. And what we also like you to do is to use these edition independent keys. So on the left here is something that you might be tempted to do if you want to read a mixture of GRIB edition 1 and GRIB edition 2. So you'd first of all, you'd say, okay, let's get GRIB edition. And there's a function call in Python, which is called codes get, where you pass this is going to be your GRIB message, this GID, and you ask for the edition. And then you test. If the edition's 1, then, I'm going to get the parameter number, so I will get indicator of parameter. And then I'm going to get the table number that parameter is in, and I get the table 2 version. But then if it's edition number 2, well, I know I need to really get probably the discipline as well, but I'll get the parameter number, and I'll get the parameter category. You don't need to do this. The better way to work is to say, get the edition independent keys. Get the short name, the param ID, and the units, and then you've got all the information you need about the parameter. And that will work with both GRIB edition 1 and GRIB edition 2. Now, the parameters themselves, I refer you to our parameter database. This is also available online at the link that we have here. The parameter database gives you information about all of the parameters that are known to ecCodes. So here you see the list. You can click on each of these links in here to get more information about the parameter. You can make searches, so you can search for either just GRIB edition 1 or just GRIB edition 2. Now, this can be a little bit confusing because, of course, as I said, this is all of the parameters that are known to ecCodes. This is many more parameters than ECMWF produces, either from ERA 5 or from CAM's forecasts or our operational forecasts. It can also be data that other centers produce, and other sensors have produced data and have stored it in our Mars archive. So the data could be in Mars, but it won't be something that ECMWF produce. And frequently what we get is somebody would have found a parameter, say this one here, and say, oh, let me get this. I'm going to try to get this from the Mars archive from the operational forecast. We don't produce this from the operational forecast. And the key here is where you see dissemination here. These are the parameters that we produce in the operational forecast. We may not produce it for all of our operational forecasts, so you may not find it for both the ensemble forecast and the subseasonal and the seasonal 5 forecast, but it does mean at least it is produced from something that's sent out operationally. So that's the parameter database. We've got plenty of documentation on ecCodes. So we have the ecCodes home. This is in our Confluence space under the user documentation in Confluence. So we've got a home space for ecCodes. We have examples which show you how to use the command line tools. We have both buffer and GRIB examples. We have examples showing how to use the C, Python, and Fortran 90 API. And we have frequently asked questions where we sometimes go into a bit more detail about how to use ecCodes for doing certain specific tasks. We have plenty of e-learning resources. These are also available online. You need to sign up to use these. We have 2 particular ones which I highlight here for decoding with the GRIB tools, which is roughly what you will do this morning. But also ecCodes manipulating GRIB and data and tools with the API. And there's one also for buffer, which you can look up for this afternoon. These, certainly the 2 GRIB ones, take about 1 hour to go through. You sign up, you go through it in your own pace. And then you can stop at any point, so it remembers where you stop, and then you can just continue. So that's a useful resource. They're fairly basic examples, but it's something that you can go through in your own time. We also, a couple of years ago, put together some Jupyter notebooks, which go through a lot of the examples we use in this part of the training course, and these are available at this link here in this repository. You can clone that and run these yourself in Jupyter Hub, for example, at ECMWF, or on your own Jupyter sessions in your own local thing. I think this uses the ECMWF open data as the example, so it's got a way there to download that data. And at this point, I've basically finished the introductory part. Has anybody got any questions? Were there any questions in the chat?
Oh, you've got me now. No questions in the chat at the moment. So just to say, those that joined late, these are recorded, so we will make them available so you can catch up at the start as well, or you can flick back in the slides at the bottom if you'd like and see what Paul presented at the start if you didn't miss it. Otherwise, any questions? Please raise your hand, open your microphone. I don't see any, so I will say continue.
So I think I'll press on then. Okay, so for the next part, we're going to talk about these GRIB tools that I mentioned that are provided by ecCodes. So these are a set of command line tools. You can use them on the Atos HPC, or you can install them locally. If you use them on the Atos HPC, they come as part of the ECMWF toolbox. So you have to do module load ECMWF toolbox, and then you have access to these ecCodes GRIB tools. So all the tools have a common syntax. All the tools start GRIB underscore and then the tool name. So for instance, you have GRIB ls or GRIB dump, for example. You then get a set of options which are they're common where they are common between some of the tools, but some of the tools necessarily have different options. And Yigit in a few minutes is going to show you through a few examples of using these tools. You then pass a set of 1 or more input GRIB files. And then optionally for tools where you're actually going to make modifications to the files, you have an output GRIB file. So we have a set of tools. There's a tool which gives you some basic information about your ecCodes installation, which is called Codes Info. I don't know whether Yigit will go through that today. He's nodding his head, so I think, yes, he is going to mention that today. I was going to say, those that I've put in grey are ones that we don't usually go through I haven't gone through in the past in this training course. But I think Yigit might actually tell you a little bit about GRIB. He'll show you GRIB get as well, I think, today as well. Then we have tools for inspecting the content of GRIB messages. So this is the GRIB ls, GRIB dump, GRIB get data, GRIB get. You have tools for counting and copying messages, GRIB count, GRIB copy, which we'll definitely look at today, and then something called code split file, which is a way of splitting messages up into smaller chunks. And this is not used so much for GRIB, although if you wanted to do some parallel processing of your GRIB data, this is a tool you could use to actually split the files beforehand to do that. It's very, very useful in buffer where you have usually many hundreds of thousands of messages in your GRIB, in your buffer files. Not so much in GRIB where you don't tend to have such a huge number of messages in one single file. There's then a tool which is kind of useful for comparing GRIB messages, and we're using this a lot at the moment for the migration from GRIB 1 to GRIB 2 to make sure that actually we're not losing information. We've also used it a lot when migrating some of our other software packages. For instance, we updated our interpolation tool in the past, and this was something that we could use to actually check that the interpolation tool had done the right thing and it was creating something which matched the previous tool. And then there's tools where you can make content to the changes to the content of the message, and also convert from GRIB to netcdf format. So you've got tools like GRIB set, GRIB filter, which is again is much more used there's a buffer filter which is much more used for buffer decoding, but there is also a GRIB filter which allows you to do a little bit of something a little bit programmatically in a command file. So you pass it a little what's called a rules file, which defines what you want to change. So it's very useful if you're making a lot of the same changes over and over again to a lot of messages in this file. That's where you would use GRIB filter. And then there's, as I say, there's GRIB to netcdf, which is really being replaced, but we still have it. It's still used, and we'll mention this to you today as well. So you can get help with all these tools. Just type the name of the tool by itself, and it returns what I've called here a Unix man-style page, which gives you information about how to use the tool. So this is this usage I showed before. This is GRIB dump, and the options that you can use with the tool. So you just pass these options. So you can do GRIB dump -o GRIB file, for example, and you get some information about the GRIB file. So the tools we're going to look at first are the tools for inspecting GRIB messages. So you have GRIB ls. This gives you like an inventory of the GRIB messages. So it's a very basic summary, line by line. So one line summary for each GRIB message that's in a GRIB file. And this is customizable, so you can specify which of the keys and the values of those keys that you want to print. Then there is GRIB dump, and this provides you much more of a detailed view of the contents of the messages. So this really can show you the keys that are encoded in the GRIB messages. You can see all of the keys that are encoded. You can get it in the format of the WMO documentation so that you can really match it across with the WMO documentation. There's then a tool called GRIB get. This works in a very similar way to GRIB ls, although GRIB ls is more for interactive use, whereas GRIB get is more to be used in shell scripts. And this allows you to print or get values of specified keys from GRIB messages. And then finally, the bit that you probably want to do is you want to get the latitude and the longitude and the values from a GRIB message. And the tool we can use for doing that is GRIB get data. Again, this is probably not a tool to use. You don't want to use GRIB get data if you are wanting to get your data into a program. You've got your model, so you've got some input data. You want to read that into a model. You are not going to do GRIB get data, dump all of these values out to a file, and then read the ASCII file, the text file, into your model. You would use the API for that. But if you want, as a user, to just get a quick view of the values and to see what the latitude, longitude, and the values are, you can use GRIB get data to do that. So I think at this point, I am going to hand you over to Yigit, and he's going to take you through the use of some of these tools. We've kept some examples in the slides, so you can go through the slides and you'll be able to see some of the examples that we've got, and this will come useful when you come to do the training, practical courses at the end of this section. Oh, I'm drawing. How nice! And you'll be able to follow and go back into the slides to look at that. But he's going to go through this now. He's got some preliminaries to get you set up. I'll give you a minute or two to get that. I think he's also just popped that in the chat.
Yes, I also put that in the chat as well.
Yeah. So if you want to follow it yourself, you can get this tarball, a copy of this tarball, and untar it into your Scratch or your home directory on the Atos HPC, and then you can follow the demo yourself and try it in real time yourself if you want. And then this will also provide the data you need for the practical sessions later. So you'll have all of that in one go. And maybe I stop sharing now, and then you can take over. Okay.
All right. Paul, thank you very much. That was a great presentation. Now I'm taking over for a live demo. So what Paul showed for GRIB tools, and especially in this first session, let's say, I will do most of the. So I will get in. We will get information about the files. We have prepared some demo files here, and in the second part, we will do much of an extraction or modifying GRIB files. So in this first one, I just put also in the chat, I'm in my Atos HPC right now. So if you do the uncompressing, I actually will do the same with you here. So, first I will start with, of course, after getting the data, I will start with showing you the data, which place we are getting the data from. So first, let me share my screen. I hope it's big enough, but let's see. I can modify the zoom level when we go in.
That looks good to me.
All right, that's good. Okay, so right now, all right, thank you very much. Right now, again, I'm in my Atos HPC, and I'm in my Scratch folder. So I will do what I wrote to you, which is simply uncompressing stuff to my Scratch. So it simply did that. Let's see it. So it uncompressed a folder called GRIB decoding. I will just go into that. And you can also, let me do that. You can also do this online. So if you choose to use ecCodes on your local machine, you can also do that. We have the link. Just download the data. You can do almost the same things as I'm doing here. So in the folder, you will see 4 different folders. The demo is what I'm going to show now, the files. Inspect will be your first practical. Modify will be your second one. And Python is simply showing us very basic Python script using ecCodes API. So I will go into demo. I will first clear everything. And now let's see what data we have in the demo folder. So you will see lots of different naming conventions maybe here, but I just do this intentionally so that you see that it's so using ecCodes we can read GRIB messages from all over the different systems. Let's say the first one is a typical open data format, which is fully in GRIB2, but we will come to that. So this you can get from data.ecmwf.int. That's our open data portal. The second one starts with A1S. It's a dissemination file but uses a legacy file naming convention. The third one is again a dissemination file that you would get from a real-time ECMWF operations, but using a new file naming convention or ECMWF template convention. The third one is again of course a GRIB file from Mars. So we have different files from different places, all GRIB, and we will get to know them with ecCodes. So how to start using ecCodes or GRIB tools, let's say. On Atos HPC, we will do module load ECMWF toolbox. Now, if I do this, it will load 2.44, which is the newest version. If I do this, I think it's the one previous version. But today's use case, it really doesn't matter. It doesn't change anything. So it's just a preference. So let's just load ECMWF toolbox new. So now we have ecCodes loaded. For any local installations, I will just show, of course, I won't run them, but I will just show that you can install ecCodes with pip install ecCodes or conda install conda forge ecCodes. So you can use these two. I won't use them, but I'm just showing them the commands here, so you can install ecCodes this way as well. So we loaded ECMWF toolbox, which has ecCodes inside. Let me clear everything. Let me do one LL again so that we see what files we have. First command, of course, to make sure that we are using the correct version of ecCodes, I can do a codes info. It's a simple command. When you run it, you will simply see your definitions and your version. We can also do something like which GRIB ls, and then you would see that it's coming from ECMWF toolbox. So these are just confirmation of installation, let's say. All right. So first, I'm gonna start with GRIB ls. So this is the most basic command, I would say, and it's very similar to a normal ls in your Linux environment, but using, looking at the GRIB file itself. So if you run it without any flags or any input or output or anything, like Paul says, it just gives you a documentation like description, usage options, and all the flags that you can use. But let me do one clear again. Let's use GRIB ls to check one of these messages. For example, the open data one. So when you do this, so let me first actually zoom out a bit so that we see proper, just a bit more. I hope it's good enough for everyone so that we see proper spacing, let's say. So we can see with just GRIB ls and the file itself, we can see all the messages and all the, let's say, default keys that it prints, some like edition, date, grid type, step, level type, and the parameter short name itself. So and let's now check one of the other files, for example, one of the dissemination file. Here we see, for example, that this has 5 messages, but 3 of them is GRIB1 and 2 of them is in GRIB2. And we can see that the default columns are different, but it's it doesn't actually, we actually have a practical on this one, so that it's the same, it's just the order is different. And then the third one would be, let's check the Mars one, which is simply output.grib1. And here we have 2 messages, for example. So GRIB LS is a great tool to just look at what messages you have in your GRIB file.
Yigit, can you increase the letters a little bit? They
Yes,
just got
okay.
smaller.
So I just did that so let's see. Okay, these are better. This one is a bit, but
Yeah,
okay.
That
This
one
is
is
better. Great. So then what we can do, we have one, we can use now different flags. For example, if I do this, and of course param ID, just like, okay, param ID is it's not short name, it's param ID. So I'm doing param ID now with the open data file. So we see 8 messages again, but we are only showing the param IDs. But this is not very good. So let's change this P to caps so that we now add param ID to the, let me make it a bit smaller, just like this, so that we see param ID at first when we use this command. So we didn't only show anything here, like not like one message, but we added with caps -p. So we also see now param ID and all the default columns or keys. Let me clear this, and now let me show you the namespaces. So if I do this, let me make it a bit bigger now. Sorry for all of these. We need to play a bit. So here you can see that, again, this is the Mars file. We did grib ls. Now let's check one of the namespaces we have, which is, for example, one would be -n Mars, so that we see now a different set of keys. So it's not default as this one, but it's a different one, and it's simply showing the Mars keys. So which field it is corresponding to. One other could be, so I will just come to Mars here. I will just remove it, and I can just add statistics so that we see values like maximum, minimum, and average, and standard deviation, for example. One other would be that, coming to statistics, removing this, and for example, parameter. We are seeing short names about parameter here simply. So, and there are some more like data, geography, time, and vertical, but I won't go into those. So let me clear everything here. The next one would be, we are still on grib ls, but simply you can choose what what columns or what keys you will show. It would be simply this command, for example. You start with grib ls -p and all the keys that you would like to show, and then the input file. When you do that, it will simply show like a center here or param ID here and level here, for example. So this was the -p flag. Now what we can do is, let me do ll again. What we can do is we can start with grib ls and then -w, which stands for where. So we are simply right now showing, we will now extract the information and show only that message. Even if the grib file has 1,000 message, when we use where and point to that field, it will show us simply that message only, or that messages. So let me paste this one. So right now we did grib ls and then -v and then short name t. So this will show me only message or messages with short name t, which is temperature. So we can see that it has only one message here. So it's a GRIB2, for example, and simply it showed only one message from 8. So it works simply something like that. And then we can use, for example, again, the same command, but let me change this to level 0. Okay, we chose now half of the messages. And or I can do, for example, count. So this is simply starting from 1, simply showing which the order of the. So for example, if I do count equals 3, it will show me the third message. So it's simply like that. And of course, you can also combine this where keys. So you can only show GRIB addition to level 100 messages, for example. Okay, one other thing would be, and then we would finish with GRIB ls. It would be GRIB ls -j, and then the Mars file, for example. So now this would show us the JSON version of the GRIB message. So if I do this, it will show me. So under this, actually, I will just do it here. So we will see them together. So here you can see that I have 2 messages here, and with -j, I simply printed in JSON version. So this would be useful within your workflow. For example, if you like to get a output with as JSON simply. Okay, then the next command would be grib dump. Grib dump is simply it simply dumps the whole content of GRIB file. And if you use that with a, for example, on the open data file, it simply prints all the messages. So you can see that we have message 8 here, or you can see that we have all the messages printed here. You can use, again, the same command, but if you come to here and add -o, it will be in WMO octet mode, so that it's a bit better structured, let's say. You can see the sections and the keys are looking better, let's say, I mean, more structured. And you can also do the same one, but let's now combine the flags so that we can use -w and then short name equals t, for example, so that it will show in octet mode the dump of the messages in octet mode, but only showing t short name, which was only one message, I guess. You can see that we run this command here, and it's simply showing all the messages and sections here. So all the messages, I meant the one message here, and all the sections until section 8. Okay, this is also done. Now let me go into the third command, third GRIB tool, which is GRIB get data. It is this one. It simply prints a lat, lon, and data values. So if you do GRIB get data and then one of the GRIB files, for example, for this one, if I just enter, it will simply pass me lat, lon, and value. Of course, this will go to eternity, so it's a huge one, as you know. So I will just clear it, but maybe we can do maybe something like this. so that it will show only the first 10 lines, so that what I can do more is that using the same command, but with a flag F, which stands for, so that it modifies this, so it shows this in a different way with a, so it will show it something like this. So with a 4-digit after the dot, let's say. And then if I again, I can combine it with some options like -W, and it will show me the same thing as you can see here, because it was the first message. But if I do this, it will now skip, because now it was there were two files, sorry, two messages in this one output GRIB, one file. One was step range 0, the other one was 360. So if I do this, you can see that the values are different because the steps are different, of course. So this one's done as well. So now what I would like to show you is ecCodes UI. So in the practicals, actually, we won't ask you to do anything about ecCodes UI, but I would just like to mention about the program itself, and then so I just would like to show you how it looks like, because it's a pretty useful one, and taking a look at the UI version of structure of GRIB, let's say. So I will stop sharing for a second because I would like to show this in VDI. So let me do that. So what is that? It's a standalone interactive application. It's built on ecCodes, and it's possible to, with ecCodes, it's possible to inspect the overall structure of the GRIB file, and of course examine the data and metadata of the individual messages. It's also available in CondaForge with 64 architecture CPUs. So it's for the modern Macs, it's a no-no, but for the 64-bit operating systems or CPUs, you can install it on your local machine as well. We will use it on VDI. So let me open it. Okay. So I will start sharing it. Okay, this one. So first of all, sorry that it's very small. I couldn't make it any bigger, so bear with me on that. You can see that I input all the files on demo, so that you can see our files here. So if I just click on them, you can see that it shows the individual messages. I can directly see that which date and time and step and level and live type it's all coming from, the count of messages. For example, for this one, A1 file, we have 5 messages, 5 different short names. The step is all the same in all of them. And we can, for example, here see the namespace. This is the default one, ls, sorry. We can see also the Mars namespace and all the other ones, for example, statistics as well. We can see a standard dump of the file. You can also see the text version or tree version like that. And also all the other sections. So for example, for this one, we have section 1, 2, and all the ones also here. So so it's a pretty useful way to check your GRIB messages. And I just wanted to show this, but you won't need this for your practicals. Okay, so my first part of the live demo is done now.